Hello everyone, welcome back to Educlynk. So today we are doing a chapter in Bottom the sets that is about two program. So all we are going to do in the chapter is firstly set notation and definitions. So firstly we are going to do the introduction to sets, then elements and membership, ways to describe sets, number of elements in a set, universal set, types of set. We're going to see all of the types of sets, empty set, finite and infinite sets, equal sets, equivalent sets, subsets, and proper subsets. And then we are going to go to the second part. There are four main parts. So here we are going to do the first part. Then we are going to finish with this. Then we'll go to the second part, which is set operations. There it is with all the operations that we're going to do with sets. So firstly, what is a set? A set is just a well-defined way of organizing a group of things. Yeah, for instance, you can have a set of students in a class, maybe a set of students in a Form 2 class. Or you can have your set can be written as a, you can contain uh 1, 2, 3, 4. So this is a set which contains all natural numbers from 1 to positive infinity. So it is a way to describe a group of things. We say, so this one like this, you call it, the set A contains all positive numbers or natural numbers starting from 1 to infinity. You can see say one Sunday all the way through Sunday. So this is a set which contains all of the weeks, all of the days of the weeks. So yes. Next we are going to do, so that's a great introduction to sets. So what is inside there is called an element or a member of the set. And this is the name of the set. The set is called set T. And these are the elements of the set. And this is a curly bracket. You represent the elements of a set inside curly brackets. I'll do that later. Okay. Now on 1.2, elements and membership. So the set is set like the set of students. I can call it S. That set is always represented with capital letters. Any set, even if it is a set of students or a set of whatever, it must be represented in capital letters. A, B, Z. That is called sets. Sets must be in capital letters. So a set must be represented as capital letter. For example, we have A equals to 1, 3, 5, 7, 9. So here you see set A has elements 1, 3, 5, 7, and 9 is 3. Now, I'm not really as here. The elements of the set are these. Here, must be something lowercase letters. When you say small letters, you know it is. So they should not be in capital letters like the set itself. So for example, you have Mimi set Z is equal to small z. Set Z is equal to A, G, C, Z. So this is the set called Z. So Z has A, B, C, and up to Z. It's advised if you don't want to write everything, you put three dots, not four, not two. Put three dots. So yeah, this is to say the elements of the set must be in small letter. Then the bracket, as you can see here, must be curly brackets. Must be this type of bracket. The brackets must be curly bracket. That means you cannot represent this set with normal brackets. Like you cannot say a set B is equal to 1, 2, 3. In this case, this is not a set. This can be seen as a matrix if you represent it like this. When you put your curly brackets, it shows it as a set. When you are doing sets, you must put it in a curly bracket. So what next? Yeah, that is all. How do you call it? How do you name it? Set? You say you say set B has elements 1, 2, and 3. Yes, a Z has elements A, B, C all the way through Z. A you say okay, yeah, just it. So yeah, that's it. Now, in this set, how do I want to tell my friend that there is 2 in the set in a mathematical way? I'll say 2 is an element of the set B. So since Q is inside, I can say 2 is an element of B, which means 2 is part of the set B. I can also say 3 is an element of B. So see that 3 is a part of B. I can also say if I want to tell my friend that 5 is not inside the set, like here there's no 5. So I'll say 5 is not an element of B. So this is called so this is when you pronounce this, when you call this, we're going to say 2 is an element of B. 3 is an element of B. 5 is not an element of B. So this sign is used to represent an element of a set. So you use this type to represent an element, and you use this one to represent any element that is not part of the set, that is not that is not part of the set. Yeah, so that's all. Now I'm going to ways to describe a set. So let me just jot the most important points. You have a set. Let's consider a set A equal 1, 2, 3, 4, 5. So how do you call this set? You say this is a set A containing 1, 2, 3, 4, 5. In that case, A equal to the set, the name of the set. B, The curly bracket is used to represent, all I said, what is it represents? Is used to show the start and end of the set. Now, how do I show one element of the set? I'll say I'm a 3 really. 3 is an element of A. How do I show one that is not an element of A? I'll say 7 is not an element of A. So what you should retain? You should retain that the set is infinity with capital letters only. You should retain that this is written always with curly brackets like this. And you should retain also that to represent an element in a set, you use this element symbol. And to represent an element which is not part of the set, you use this not element symbol. So, ways to describe 1.3. Ways to describe a set. So there are too many ways to describe a set. It is the listing method. The first method is the listing method. So how does it go? This is a method where it lists all the elements that are inside the set directly. As it is possible to be listed, just list them. Like what we have been doing, for example, we have A. Instead A, let's take that example. I'll say A is 1, 2, 3, 4, 5. So how do you describe this set? Describing doesn't mean naming. How do you name the set? How do you describe it? So you say this is the set A. The set A contains 1, 2, 3, or 5. Or you can say the set A contains integers from 1 to 5. That's how you describe it. So there's no, well, you see the difference when we reach on the second one, or the second example, to see the difference between this one and the other example. So let's take another example. And I have a set B equal red, blue, green. So how do you describe this? The set B contains 3 colors: red, blue, and green. So now let's see how it differs from the other methods. The second method is called the set builder. It's called a set builder method called a descriptive. The set builder method or descriptive method. So here it describes the property of the set. It does not actually name the set. Like here we say the set A contains 1, 2, 3, 4, 5. Here it describes the main property of the set. Like this a rule that defines the elements. For example, we have various squares A equal x and the sun. Even number. So you can also write it like this. I've forgotten the method 1 has another name. It can also be called the roster method. The first method can also be called the roster method. So here the second method is this set builder method or the descriptive method. The first method is a listing method or the roster method. That's good. So this method is a little bit more complicated too, but quite as easy as we want. So the example that we had is, okay, so then I'll give you a set like this. How to describe this set? How do you know what it means? You see the curly brackets, you shows it's a set. You see x is an even number, then a comma, 0 less than x less than or equal to 10. What does this mean? This means A is a set X such that it is an even number from 0 to 10, exclusive of 0, because there is no less than equal to it. It is just less than. So 0 is not considered. So how do you represent it? If you want to write it in this form, how are you going to write it? You're going to say x is equal to A is equal to x, such that x is an even number from 0 to. So what are even numbers from 0 to 10? 3 half, 2, 4, 6, 8, and 10. So this is a set. So this is another way of representing a set, which is called a set builder method. You see, you build your set yourself. This is just a description of the set. The set builder method is just giving you a description of the set. It's just telling you x is an element, is an even number in between 0 and 10. So you are the one now to think, what are the even numbers between 0 and 10? You write them 2, 4, 6, 8, 10. I write 10 because it's less than or equal to. If it was just less than, I'll now write it 10 because it told me it's less than 10. So I'll stop at 8. I'll remove this comma and move 10. I'll stop at 8. Since the set is from 0, if this was less than or equal to, I'll write 0 wherever there's arguable. Some people will say 0 is an even number, some people will not agree. So let's not just write it to that now. So here is 0 less than, so I can write 0. I start with 2. I start with any number which is greater than 0. So you have 1. Is 1 even? No. So I write 2. Then I write 4, 6, 8, and 10 because this was less than or equal to. Alright, let's do another example of a set builder. This is another example of the set builder method. We have set b equal x, x, set b equal x such that, so when you see these two dots, you read it as such that. Let me just write it here. Let's do a very important point. When you see these two dots, you read it as such that. So here it says b is equal to x such that x is a vowel. So then they said b is equal to x. Now what is that x? X is a vowel. So how do you represent b in listing method form? So you say b is equal to x where x is a vowel. What are vowels? You have A, E, I, O, and U. These are the 5 vowels. So you have listed it, you have listed it, you have listed this set, and you have changed from this set builder forms by listing method form. Let's do another last example. We have h is equal to x Let's let him come to. So this example says, how do you read this? I'm going to say h, the set h is equal to s, to x, such that x is an integer in between -3 and 3. So when you see x in the middle, it means it is in between -3 and 3. Given that the sign is this, the sign must be this. If it is like this, even if it is like in the middle, it does not mean receptive. But if the sign is like this, and it is in the middle, it means it is in between -3 and 3. So I'm sure you know what is an integer. An integer is just a positive number, a positive whole number, not a positive, a whole number, which is not a decimal. They can be positive or negative. So that's an integer. So when you say x is an integer in between -3 and 3, how do we represent it in the listing method form or the roster method? So I'm going to say h is equal to x, where x is an integer. So you know what is an integer, and you said they said you should start from -3 and end at 3. See that here we have less than or equal to, like this, with the equal to sign under. It means you include the -3 actually when writing it. So you will put here -3, -2, -1, 0, 1, 2, and 3. It goes like this. Right. So that is how you present. So those are the two methods, the two ways of representing it, of describing a set. So let's go now to the number of elements in the set. Maybe it's all way for. Number of elements in the set. So let's imagine we have the set A equal to 1, 2, 3, 4. We have another set B equal to 1, 3, 5, 7, 9, 11. We have another set C equal to 5. How do you represent the number of elements in the set? How many? Okay, let's imagine. Let's start with set A. How many sets? What is the number of elements in set A? Yeah, 1, 2, 3, 4. So there are 4 elements. 4. How do you represent it? So how do you write in set form that there are 4 elements in set A? We're gonna write N A equals 4. We write it like this. Or we write it like this. This will most likely be used. This is what is most widely used in school and everywhere. But this can also be used to represent the number of elements in A. So yeah, this means the number of elements in A equal to 4. It means there are 4 elements in A. How many elements are here in B? We have N, B is equal to 1, 2, 3, 4, 5, 6. 6. So you should know that N of something represents the number of elements in that set. Let's write it here. N of the set is equal to number of elements A. So kind of A represents the number of elements in A. So there's another example. Yeah, n of c is equal to what? 1. Now, let's do a more tricky example. We ask f is equal to, they set x is equal to 1, 2, 3, 3, 4, 5, 5. We have this set like this with repeated terms. We have 3 and 3, then 5 and 5. What is the number of elements? What is the number of elements in f? Some students we attempted to count elements 1, 2, 3, 4, 5, 6, 7, that's it. F is equal to 7. But that is not the case. Here, when you ask about the number of elements, you don't consider repeating elements. This is one element. This is another element. This is one element. If this repeats, you don't count this. This is another element. If it does not, since it does not repeat. If this repeats, you don't count this. So how many elements are they set F? 1, 2, 3, 4, and 5. They ask for how many repeating elements are there. You can count all of them. But how many elements actually are there? And see, there is 1, there is 2, there is 3. There is another 3, but the element is 3. There's no actual number of elements. So there is 3, there is 4, there is 5 too. So if they're repeating, you don't count them. So here it is. So it should not fall in that trap. If you see repeating element, then they ask you for the number of elements. Write it as 5. Let's take another example. So the set H is X. So it's got X is the letters in the word X is the letters in the word book. So if they give you this, how will you represent the elements? Where sets minimalistic form. So I'm going to represent as this. Is equal to B. Book has how many letters? 1, 2, 3, 4. That's 4 letters. You have B, you have O, you have K. This is how you are going to represent it. You'll not write B, O, O, K. Because they said X, so that X is the letters in the word book. How many letters are out there? You have B, O, and K. So when they ask you to represent this, you will not write the number of letters. You write the letters that are in that word. Yeah, letter B, letter O, letter K. So what is the number of elements? Yeah, number of elements is number of elements of H is 3. So if you don't represent it like this, you might have difficulties find the number of elements immediately because you might be tempted to just count 1, 2, 3, 4. If you write it like this, you will notice that the number of letters, the letters that are used is letter B, letter O, and letter K. There's no other letter. So when you are representing it like this, you see easily that it's just 3. That's just 3 elements in it. So yeah. Based on that example, we have I equal letters in mathematics. I was the letters mathematics. So you can try it to find the sets in the listing method. Find the set and then find the number of elements in the set. So what is that set? What is the set going to be? You have I is equal to, you have n how many times? 2 times. We write our n and cancel it and cancel it, not be confused. Cancel it and not parallel. Then you have what? A. Right here A. Cancel here, cancel here. Hey, how about T? Right here T. Cancel here and cancel here. Hey, have H. Right here H. Cancel here, there's just one H. Hey, how E? Right here E, you cancel. They have R and C and S. So let's just set like that. How many elements are in that set? N of I is equal to 1, 2, 3, 4, 5, 6, 7, 8. So write n I is equal to 8 like that. So that's all. I'm sure now you can represent number of elements in the set. So let's take a look at universal sets a bit. So we have 1.5. Universal set. So it is represented like this universal set. So what is it? So it is just a set which contains all of the elements in a particular context. Like for instance, you can be talking about the days of the week. You can have a set A which is equal to Monday, Tuesday, and Thursday. These are some days in the week. Now, what will be the universal set here? The universal set will be all of the days of the week. Monday, Tuesday, up to Sunday. See, if you don't want to list every element in a set, you must list the first two, then the last, putting 3 dots in the middle. If you leave it, I don't put the last, we don't know where I ending. Because it is a finite set, I don't put the last thing. If it is a finite set, you are going to reach finite and definite sets. If it is a finite set, like if the set can finish, if the set has a defined number, if you can count the number of elements in that set, you must put the last set if it is sooner. So you can either represent like this with 3 dots in the middle, or with the last set, or you will list all of the elements, like you list them one by one: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So our universal set here is this: Monday, Tuesday, Wednesday to Sunday. You see, it englobes all of the days of the week. So universal set is just a set which contains a global life, everything in a particular context. Like here, if you have the set of days of the week, everything in this context of days of the week will be all of the days of the week. So likewise, if you have a set containing 1, 2, 5. Okay. I have 1, 3, 5, and 3,000 and leave it like that. So this is a set which contains all of the part numbers, starting from 1 to positive infinity. So what will be my universal set here? Because every set is either a universal set or has a universal set. So this set, if I'm talking about every odd number, it's already a universal set because it already contains every odd number. So if I have another set here, so this set I can say that B is equal to my universal set. We're going to talk about equal sets later. Also that this B set B is equal to universal set, where the universal set here is the set of all odd numbers from 1 to positive infinity. Alright. So that's it about universal set. So if I have the set which says student's name, if I have the set by set B, let me do the C. Set C is equals to students in Form 2. It says this is students in Form 2. My universal set will be all the students in the school. All students in school. Yes, because this is already englobes everything about the students in that school. So now on cancel everything, we take a part of it and name it students in Form 2. So that is it about universal set. So let's go now to types of sets.